So if I have a, do we know what that is?
No.
Well, what's it represent? A number, right? And then I have the square root of 2, whoops, I have the square root of 2 times a, right? This is also a number. So these right here are constants, believe it or not. Because a will not change mid, it will change, I could change it and plug it in, but whatever value I set for a, it remains that value. And then this upper limit here, same thing, it's a constant. And I want to, so basically I'm going to find the area under the curve of x dx. And let's think about what that means. I have, what does the graph of x look like? Well, the graph of x looks like this. Y equals x. And I don't know what a is. A could be anywhere, but wherever a is, if I multiply it by the square root of 2a, I'm going to get this area under the curve. Wherever it is, it'll shift anywhere. So let's figure out what that is. What is the antiderivative of x?
X squared.
It's x squared over 2, right? I mean, like I said, if you don't know that, you can just think about it. What's the derivative of x squared over 2? You toss the 2 to the front, divide by 2, they cancel, and you get x. But we have to evaluate this from a to the square root 2a. All right, so now how does that work? Well, we start with this one first. Remember, it's b minus a, where this is our, so I'm going to say the square root of 2a squared all over 2. What am I doing? I'm plugging in that upper limit into the function x squared divided by 2. And then I'm going to subtract a squared all over 2. Does that make sense?
Mm-hmm. Yeah.
All right, so now what is this? Well, this squared becomes 2a squared. Well, I've got 2a squared minus a squared all over 2. That just gives me a squared over 2.